Careful study of forces requires you to study forces in one direction of your coordinate system and the other direction of the coordinate system, each of these being independent of each other. So we should be studying the forces in the x direction and in the y direction. In the x direction, well, weight is only in the y, and in the x, if we consider the net force in the horizontal direction, there's just one. I see the x component of tension, and it's to the left, so let's call it negative. And in the vertical direction, I see weight pulling down and this part of the tension pulling up, the y part of the tension pulling up and the weight pulling down. Now, she is neither accelerating up or down, so at least in the y direction, I know that the net force is 0. So from that, I can tell that Ty is equal and opposite to the weight. Ty is up, the weight is down. There I go. They're equal. Together, combined, they add up to 0, so they must have equal magnitudes. Well, I know what the weight is. Weight is equal to mg. And if weight is equal to mg, then that's what Ty is equal to. Weight's equal to mg, so Ty must be equal to mg because they're equal in opposite directions. So now that I know Ty, heck, I think I can find Tx. And if I can find Tx, then I know the net force on this object, and this net force is going to be accelerating it. So how can I transfer my knowledge of Ty to Tx? I'm going to use geometry. I'm going to remove this L. It's in here. It's interfering. Well, if this angle is theta, these two are parallel. These are opposite interior angles. So by rules of geometry, that angle is theta. And I know that angle, and this is an adjacent side, that's an opposite side. I can use the rule, the trig rule, tan theta equals opposite over adjacent. The opposite is Tx. The adjacent is Ty. I know tan theta, I know Ty now. Ty is opposite of weight, so I can find Tx. Tx is equal to tan theta Ty. And let's remember Ty is equal to mg. So now I have a good idea of what Tx is. It's mg tan theta. And I still don't know her mass, but I have a suspicion that, especially if I watch different riders, people who are light and people who are heavy have the same angle. So I'm kind of guessing that I'm going to be able to get rid of this m. And let's see why that's the case. So here is my tension in the x direction. It's pointed inwards. So I can substitute in here. I can say that's inwards tan theta mg. And it's my net force in the x direction. There's only one force, and all forces cause accelerations. It's going to cause ma. It's going to cause this object to accelerate, and I have an acceleration in circular motion has a special form. mv squared over r. So let's see if we can put it all together. I'm going to different color pen. we have our net force in the x direction is tan theta mg, and that's causing us to accelerate in a very special way in circular motion. So our ma is equal to m v squared over r. Masses cancel on both sides. Radius, I can multiply and then take the square root. So velocity is equal to square root of negative tan theta radius g. That's it. Well, we did end up with a negative sign here. Of course, if I had analyzed the drawing when she was on the other side, this would have been, my tension would have been this way, and it would have been, but also I could say that, well, my tangent, my tx, I could have put in, that's this way, which was also negative. I could have put a negative there. Tan theta, opposite. So, guess what I'm saying is, you have a negative sign here. It is a matter of perspective. I could have analyzed it this way, and indeed, if I was really fussy, I would have put a negative tx there, and then that would have canceled out this one. I guess I'm saying is, I'm going to remove that negative sign there. It is there. It wouldn't be there if I'd looked at it in the other when it was on the other side. What it means is at this moment the acceleration is going to be in this, towards the center. But I'm going to ignore that negative sign inside the square root. Just take the square root, figure out the velocity. So now we know how quickly she's spinning. We know how far, how quickly she's traveling. We know how far it is around the the circumference of the ride. You can come up with a time that it takes for her to circle once around.